Okay, I think people did registered. So as Dwayne, you can maybe change the slide. Um, yeah. So hello everyone and welcome to Cloud Lunch and Learn sessions. My name is Marcus Soldo and today we have our first session of our series of sessions related to Azure Fundamentals. We have Dwayne with us. He's going to explain you much more in details about the Azure Fundamentals, cloud concepts, and Azure structure. I'll hand over to the Dwayne, but before I do that, during this session, if you do have any questions, please write those questions in the chat and we will answer it during the Q&A session. So Dwayne, go ahead.
Thank you very much, Marco, and welcome everybody to this, the first of our Azure Fundamentals Series. So over the next 4 weeks, I'm going to try and bring in all of the Azure Fundamentals course into the Cloud Lunch and Learn. So hopefully after this month is over, everybody feels comfortable and will be ready to sit for the AZ 900 exam if that is your goal and direction to get started in the Azure environment. So today we're going to talk about the core fundamentals around cloud, as well as get into a little bit of the structure of Azure. For those of you who don't know me, my name is Dwayne Natwick. I am a Microsoft Azure MVP and a senior cloud training architect at Opsgility and Skill Me Up. I do author and do training at Skill Me Up and Opsgility. I'm also been a solution architect, product manager, been in IT industry for a long time, and have multiple Azure and 365 role-based certifications. I'm also an MCT and regional lead for that program, and you can catch me on social media at my blog site, LinkedIn, Twitter. Feel free to reach out. I'm going to be providing as well another survey at the end of this session as well. I'll put in the chat, which I would like to ask that you provide a rating on that, to do that survey. It helps with my MCT renewal. So if you can do that, I appreciate that. So what are we going to cover in this session? We're going to hit on the core cloud concepts, cloud services, cloud architectures, and then we'll go through the Azure geographies and Azure regions as part of this. We're going to get a little bit deeper on the follow-up sessions. This is going to be for those of you that might be around cloud technologies already, a little bit of a review, but it's very important as a foundation for this exam, and it is a very core objective area within. So if you're new to the cloud architectures and cloud data centers, data center concepts, this might be new to you, but otherwise it's review. But stick with me. We'll get into the deeper stuff in the coming weeks. But as part of just providing you guys with the full training and the full content of the Azure Fundamentals exam, we need to cover this. So, cloud services. What is cloud computing? And to think about cloud computing and think about how that has gone, how that has evolved from just having a server within your data center that was handling one workload to where we are today with our cloud environments and our virtualization environments. We really start to get into what cloud is and what is the power of the overall cloud concept. And really it's around mainly around compute, storage, and networking are the three main components that you talk about when you're architecting an environment within the cloud. And those are and how the sharing of those resources within an Azure or any other cloud type environment, even if it's your own on-premises data center, we are in a cloud type architecture sharing those resources across all of our workloads in one way or another, rather than having a single server that was for that single workload. What VMware and OpenStack technologies and Hyper-V have all done is they have created this shared architecture for compute, for storage, as well as for networking in terms of a software-defined network, rather than having switches and plugging physical patch cords into a switch that goes directly to a server. And then on the back end of all that, then you start to find, you have then a lot of those analytics tools that can be then used to gather information out of your what you're doing within the environment, how your environment's performing, telemetry data that can be used to analyze how your data is being utilized, or how people are accessing data within your internal infrastructure, as well as maybe your websites and inventory and things like that, to make you a much more efficient organization. And then we talk a lot about Azure and Microsoft, but there are obviously other cloud providers out there, such as Amazon and Google are also ones to think about when you're talking about cloud computing. And when we're thinking about cloud computing, we need to think about the key cloud concepts and why would we move into a cloud environment, specifically one that's outside of our own data center. And some of those benefits are the high availability, the ability to have quick scalability of resources, to stand up compute resources on a quick basis, and that also kind of goes into elasticity and the ability to expand and contract your resources quickly, and be able to also have the fault tolerance of high availability, being able to have a global reach. If your organization is based in the UK or in the United States, and you need to provide a lower latency access on in somewhere else in Europe or in India or Japan, having the ability then to stand up those resources quickly is a driver to look at Microsoft Azure. Again, it's making you then also very agile and provides you with additional disaster recovery as part of that high availability and fault tolerance environment. You can have a higher level of business continuity in your environment. And then the security aspect, which is one that becomes kind of a debate around your environment. Is it more or less secure than having it in your own on-premises environment? And that's a debatable approach and discussion to have, but with the ability and the capabilities of Microsoft with their threat intelligence, their global threat intelligence capabilities, their machine learning capabilities, their regulatory and compliance attestations and things like that, there are ways that it can provide more security than your own environment, because all of those capabilities and controls are there and can be turned on with just a flip of a switch. So those are some things to really think about when you're looking at going into a cloud provider type environment versus your own type of environment. And a key point here around the cloud environment and with cloud providers is economies of scale. And what we mean by that is when you're building your own data center, you're building it for you. And in that case, you are investing in that environment, you're paying for that environment, and you're not necessarily going to gain any benefits from a cost standpoint from distributors, unless you're a huge global enterprise, a Fortune 100 enterprise over the global enterprise, where you can maybe leverage some of that buying capability to decrease your costs. What Microsoft and Amazon and Google have done is they have taken their own enterprise infrastructure and their own capabilities and buying power in their own environments, and they have taken that and spread that across the customer environment, and it reduces then cost and gains efficiency because they're already operating at that large scale, and they're then putting that out there to other organizations at a fraction of the cost that it would be for that organization to go out and invest in that size of an infrastructure, or what they might need from a global scale for renting data centers and things like that. So there's a lot of benefits there then to move into those cloud environments. And in addition to that, you're not just taking advantage of the economies of scale where your costs are decreasing. You're also moving how that is being affected on your balance sheet from a capital expense of buying equipment over and over again on a 2 to 5 to 10 year cycle, to making it an operating expense. It's just right there with your internet provider costs. It's the expense then that can be itemized on your balance sheet, on your taxes, and be that just monthly and yearly expense that is maybe fairly predictable, no upfront cost from that standpoint, and you're only spending, rather than being a large multi-million-dollar investment that you're making every 5 years, and may not have the ability to do that. And depending on how your business is performing, you may not have the capability to make those investments. So you can initiate and expand a lot more agile and nimbly when you are utilizing a cloud provider, because it is an operating expense now, and it's a lot easier to go to your board or the president of your organization and say, hey, I need to get approved a monthly expense of $1,000 or $2,000 for this new application, rather than saying, I need to build this new application, I need $500,000 to build it, and it's going to cost us $2,000 a month to manage it and run it. So those are some things that you think about when you're moving into the cloud provider type model versus building your own data center on premises. And in addition to that, then we're also talking now, we're on a consumption-based model where we are now paying for only what we use and what resources we use. So where we might have servers within our data centers on premises that we are only using, we need to build for and estimate for our full capacity. And I always use the example, and we're coming up close, Christmas shopping season is going to be starting soon, and we think about a web server or a e-commerce server that is running in an on-premises data center that 8 months out of the year is only running at 25% capacity, but bounces up to 80-90% capacity during November to say January or February, just to cover after Christmas sales or returns. We're underutilizing our resources for 8 months out of the year, just because we need to build those resources to support our peak performing times of the year. Another thing would be for line of business applications, for processing our books on a monthly basis. We may only 25 days out of the year be running at 25%, but it spikes when we batch process everything for the end of month books and that spikes up. we're mismanaging and misusing our resources at that point. So at a consumption-based model, we're only paying for what we use. So when we need that extra capacity, we can pay for it at that time, and then it goes back down to utilizing what we need when we need it. So we've talked about a lot of the benefits here in that first section and why we would think about moving to the cloud. Let's talk about the different cloud models, because I've kind of hit on a few of those as we've gone through, but let's get a little bit deeper into the three primary models, like public, private, and hybrid. So the first one is public cloud, which the public cloud is what we talk about when we're talking about Microsoft Azure, when we're talking about AWS, Google. It is cloud. It's owned by a cloud service provider. It provides all those resources, and it's providing that to multiple organizations. It's not a one-to-one where that enterprise owns those resources. Microsoft's providing, as I stated before, all that compute, storage, and networking that they have purchased. They are parsing that out for multiple vendors and multiple organizations to use those resources, and therefore, like I said, you then have that benefit of economies of scale. The key point here is typically you're going to access it through a secure network connection, typically over the internet. We'll talk more when we get into the nuts and bolts of networking about express routes. AWS has their direct connect. Google has a similar dedicated circuit that you can purchase to securely connect and create essentially a private connection to their data centers, which some enterprise organizations prefer to have for that secure tunneling. But typically on a basic level, it's a IPsec VPN tunnel from your data centers to the Microsoft data centers, and that's your public cloud connections. Private cloud is an on-premises type data center or a private data center, such as a co-loc type facility that is the organization-owned equipment, an organization-owned environment. They might rent, say, a co-location from, say, a rack space, but they are providing the equipment. They own that equipment. They've made the capital expenditure of that equipment, and they're utilizing that. And that is their own private environment. It could be a cloud environment running VMware, OpenStack, whatever, but they are utilizing their own equipment. They're operating that as their own data center. And then the hybrid cloud, which is a combination of the two. And you may hear the term multi-cloud out there. There's also community cloud, which is a term out there. Community cloud used to be in this exam. It looks like they pulled it out over the course of the last year or so. But we typically talk about public, private, and hybrid. And hybrid is the public and private clouds together, which is going to be probably, I would say, most of the time what you're going to see in most environments. They're going to have some legacy applications that are still running in their own on-premises data centers or in a co-loc that they have not migrated into a public cloud environment. And there is connectivity between the two. And that is that hybrid cloud and what probably is the most popular architecture out there, unless you're a startup that's decided I'm going to be cloud native and everything's going to be in a public cloud. And here's the comparison between those three. So I talked about that a little bit when we're on each slide, but the key point here is we are talking about in a public cloud that we're not going to make a capital to scale up and create that environment, to architect that environment. You can quickly provision and deprovision applications in there. From a DevOps standpoint, very helpful for testing, development of applications, and you're only going to pay for what you use. In a private environment, again, you're making a capital expense, and you're making those expenses. As you depreciate equipment, you're going to need to upgrade operating systems and pay for licensing and all of those things. But you have complete control over those resources and over the security. And then the hybrid then is the marriage of the two, where it provides you with some flexibility for those highly secure, highly regulated type applications. You may need to have that in a private cloud, and then for other workloads and applications, you can move those to a public cloud environment. You have then the best of both worlds from a security, compliance, and legal requirements as well, because many of the the attestations and compliance requirements for different regulatory requirements, GDPR, and things like that, those controls are available within the public cloud, and you can pull those in a lot of times into your private cloud environment. And we'll talk about that in a couple of weeks when we hit into governance and compliance as well. So I think I see a question here. How common is it to mix public clouds? So that's a really good question in terms of Azure with Amazon or Google. And I hit on that when I mentioned multi-cloud in the hybrid cloud slide. It depends. I've seen organizations that have utilized certain services within Amazon, as well as with Azure, where they've had their SQL environment within a Azure environment, because SQL licensing, because Microsoft owns SQL, is much more beneficial in Azure than it is in AWS or Google. And then utilizing a lot, some of the storage capabilities of like Glacier and data lakes and things like that within the AWS environment. And that's what when we start talking about that multi-cloud environment. And that multi-cloud term is you're utilizing not just your private cloud on premises and a public cloud provider, but you're using multiple public cloud providers. And that's kind of where the definition of multi-cloud comes in. And we do see that. One of the misconceptions around multi-cloud is and around using multiple vendors is using multiple vendors for the same workloads. And I'm not seeing a whole lot of that. It's usually one service within one of the cloud providers might be less expensive than the other, so they utilize that. And of the cloud providers, Microsoft is probably the only one that has really embraced that whole multi-cloud infrastructure from a standpoint of they've built a lot of capabilities of managing and monitoring the other cloud providers such as Amazon and Google within the Azure ecosystem, such as in Azure Sentinel or Azure Arc, and they've embraced that, where some of the others kind of push it away or discourage it. So, it's not a hugely common practice right now. It's usually somebody picks one and goes with it. But I have seen some organizations, depending on what they're doing within their environment, choose to have multiples as well. And it's been typically what I've seen has been Azure and AWS. Just looking at another question here. Yeah, good question, Andrew, regarding, again, for multi-cloud and hybrid. Is there any best practices or pointers to keep an eye on and factoring in security? It's always important to take into account and to build in and make sure from an architectural standpoint that you've built in what policies and governance you have that you want within your organization. And one of the things around Azure, specifically around Azure Monitor, is that Azure Monitor can be, the agent for Azure Monitor can go on-premises virtual machines. It can go in on any virtual machine essentially. So you can put it on AWS virtual machines, and you can monitor those things into Azure Security Center for visibility on your secure score and security best practices, as well as into Azure Sentinel allows you to connect to AWS CloudTrail as a data source. And we're getting a little bit beyond the fundamentals here, but those are some important things to think about around, when you're thinking about governance. And we could talk more about it when we get to the governance standpoint, but that from a high level, those are some ways to bring in best practices. Make sure that you have determine what your policies are, your baseline policies, and then make sure that whether, if you are utilizing a hybrid cloud or even a multi-cloud with virtual machines on AWS, that you're utilizing, Network Watcher, Azure Monitor, Log Analytics. You're putting all of those tools into those environments as well. So that's pulling it into your Azure environment. So let's talk now about the types of resources, and this will be, we're going to talk about shared responsibility model, and we're going to go through the different cloud models that some of you probably already know and love, such as infrastructure as a service, platform as a service, and software as a service. So we'll come back to this in a little bit further detail, the next slides will bring a little bit more around it. But we have our three models of infrastructure as a service, platform as a service, and software as a service that kind of are the three key cloud models when you are consuming cloud services within the Azure environment. And then on the far left is the on-premises type environment. When you own and control everything, as we said, in a private cloud, everything is your responsibility. You aren't sharing any responsibility on any of it. It's you need to build your organization to effectively handle the management, the monitoring, the control of this environment. However, when you start moving across, some of that responsibility starts to become the cloud providers. From a Microsoft standpoint, AWS, Google, it is the same regardless of who is managing it as the cloud provider. The responsibility shift is the same regardless. And when it's an infrastructure as a service, you have the most control over that environment. You control everything down to the operating system of that virtual machine, and even some of the system, the control of that virtual machine still lies on you as well. While those foundational pieces of compute, networking, and storage still start to fall on the cloud environment, as well as the physical building security. All those physical pieces and components now fall on Microsoft. As we move across, those responsibilities start to become more of the cloud provider's capabilities, such as from a platform as a service, all of the operating system, the malware, the virtual machine, the virtual machine capabilities, keeping the operating system and keeping that virtual machine up to date and functioning and performing, as well as the physical compute, networking, and storage, now falls all on Microsoft. All you're ultimately doing is you're loading your application on that environment and managing the access and control of that data at the identity and access management level, and the having it turned on for proper encryption capabilities and things like that. protecting all of that is now your responsibility. And then when we get to software as a service, such as Microsoft 365, everything in terms of the application is now Microsoft's responsibility all the way down the stack. All we have as consumers is the ability to now, how our data is shared and protected, as well as how our users are accessing information is still our responsibility and always our responsibility. So if there's ever any breach in data, there's the most of the legal ramifications if you are storing one of your own customers' data and there's a breach in data, the legality falls on you as the organization, not on Microsoft. Now you could essentially potentially try to prove negligence to Microsoft that something, one of their controls failed or something of that nature, could give you some level of recourse for that breach. But ultimately, you are going to have to do that as a consumer from a legal standpoint and jurisdictional standpoint of the whatever entity is suing you. It's going to be your company that's going to get sued. So that's why you start hearing that identity is the new security perimeter, because of the fact that you need to, across the board, make sure that you are taking proper steps in how data is accessed, how information in your environment is accessed. So to talk a little bit more about each of these now, you can see, in terms of a infrastructure as a service environment, in this diagram, what it's showing is, here are the pieces that Microsoft controls in terms of the cloud provider. It's pay-as-you-go IT infrastructure. You're renting the server environment, the virtual machines, the software-defined network, the storage, and the operating systems all are coming from the cloud provider. But you have the control to manage that, how you see fit, put what controls in place you want to put in place. But the physical environment of having the physical storage, the physical server environment, the physical networking, firewalls, and the data center all falls on Microsoft. And then when we take it a step further in terms of a platform as a service environment, now Microsoft's taking over the operating system and all of the development tools, database, business analytics. All of those things now are obscured from your control. You are simply putting and deploying and building and testing an application on top of that platform at that point. It's still, ultimately compute services. It's an operating system that's still running within the Microsoft environment, but it's now providing you with all of that. You don't have to manage patches anymore or operating system upgrades, things like that. That's a good question, Deepak. Why is there no function as a service in this model, or FAAS? Actually, if you stand by, I think we do actually. It's actually not in this presentation, but function as a service is kind of a in-between platform and software as a service. It's outside of the. It's not a typical objective around this exam. You might have something around functions. Function as a service is really, again, running code on a platform. So it's still platform as a service, but yeah, we're getting into this FAAS terminology for function as a service, where instead of deploying a software application, we're deploying code on top of that app service within the Azure environment, and that's become a common terminology of function as a service. I think it's outside of the realm of the Azure Fundamentals course. It comes in more in the architect. We talk about it a little bit more in the administration and architecture type courses. But when we think about function as a service, it is a platform as a service type service anyway. It's just a subset of that. And then just to kind of sum up these, when we're talking about the software as a service, Office 365, having, Exchange Online, SharePoint Online, OneDrive, all of those type of things fall into that software as a service. You're getting your apps and everything delivered right to you, and all you're doing is you're accessing your data. You're accessing, from a organizational administration standpoint, what you're doing is you are now just making sure that the proper identity management and data protection is in place for your environment. You're no longer worrying about the application running, the back end compute services, the storage services. Those are all taken over by the cloud provider. And if you're talking about like Microsoft 365, that's obviously Microsoft. So here's kind of a quick comparison of the three. Infrastructure as a service, you have the highest level of ability and control over that environment. You configure all the hardware for your application. So you have the most flexibility to what you can do there, because you can still get into the operating system if you have to make tweaks to the operating system. If you're running a SQL database within the environment, you can make performance tweaks to that virtual machine for the SQL server. But if you're moving that then into the platform, you're no longer having to do patchwork. You don't have to do security patches, operating system upgrades. Those are now handled by the cloud provider. And then SaaS is that pay as you go. You're going to purchase that application online. You're going to have access now to that application. Microsoft 365, such as Adobe's cloud services. You can buy those services. Adobe Photoshop, get those services, buy those services, and then immediately consume and utilize those services. So the last piece that we're going to talk about in terms of this week's objectives is the core Azure architecture and components. We'll get into the physical structure of Azure, its geography, and understand some of the ways that Microsoft works in terms of providing cloud services. So key point here is around Microsoft. Microsoft provides the flexibility and scale by putting by breaking their environment up in terms of regions. I apologize, being a lot of you are not in the United States, but this is Microsoft's slide, and they put a United States slide on here. When you look at the United States, for example, you can see that there are a lot of geographic regions within here, and that provide then the ability to choose a region that's closest to you to decrease latency, as well as provide some resiliency within the environment. And each region, when you look at the U.S., the U.S. is actually a good example because the regions are a little bit different. From a geographic level, each dot on this graph is a region, but it's all in one country. So when you think about how those regions are set up, you can select that region that's geographically closest to you, and then also provide some resiliency and high availability in your environment by picking one that's by replicating to another region. And one of the things to keep into account when you're thinking about regions is that each region is paired. So if we look at the UK and look at the UK West and UK South are paired regions, and what each of those regions has is they're prioritized, and the speed of the backbone behind them has very little latency standpoint. So if you're building a high availability type environment, it's important to look at your paired regions before you utilize one, two that aren't paired. So you might not want to pair, Southeast Asia with North China, because you might have some latency there. But Southeast Asia and East Asia can be utilized. East U.S., West U.S. They're usually 300 miles of separation between these regions. So they're meeting all of your disaster recovery and business continuity capabilities from that standpoint. And it's important to know that the updates that are rolled out can sequentially between these regions as well. So if you're using say East US and West US 2, you might find that they could have updates that happen at the same time. So you could cause a failed application if East US goes down during or when East US goes into an update cycle, because West US is also going through an update cycle. So it's important to know these regions and understand, if I'm using East US, I want to use West US as my paired region, because they aren't going to have system updates at the same time. And then from a geography standpoint, understanding just, the data resiliency and residency and compliance in terms of geographies, specifically around GDPR capabilities and the compliance around where data resides, and the geographies themselves are categorized as Americas, Europe, Asia Pacific, Middle East, and Africa are the 5 geographies that are part of the Azure environment. So, so it's important to understand that regions are just specific data center locations. They aren't necessarily a specific country of origin to think of. When we're talking about then, geographies, you can see that, when I mentioned the 5 are generally continental type statements. So it's important to understand the difference between the two, and don't get regions. Don't fill your head with regions in terms of countries. There's multiple regions within within various countries. Especially when you think about the United States, there's a bunch of regions within the United States. And then around availability, building different taking advantage of the availability options within a region and within how you architect your environment are important to how your service level agreements for availability within the Azure environment take place. This is specifically would be around building a infrastructure as a service type environment, where we're looking at a single virtual machine. If you stand up a single virtual machine, we have a 99.9% service level agreement. So Microsoft's going to say, that 99.9% of the time, this is going to remain available to you. So, that you'd have to look up the numbers on it. I don't know them off the top of my head. I think in terms of like a month, that's up to an hour downtime, I believe. If you look then using availability sets, where you have more than at least 2 virtual machines, and that's what it's kind of showing in this slide, is that there's at least 2 virtual machines, but it's showing it as up to 6. It adds then it upgrades that to a 99.95. So that is an availability set, is having 2 virtual machines, but they are in the same data center as an availability set. They might be on they're going to be probably on different racks or on different hosts, but they are within the same data center environment. An availability zone then takes that a step further, and we didn't talk about it when we were talking about regions, but each region has data center buildings that are geographically separated as well, with separate networking, separate heating and ventilation. They're separated and physically two different paths of connectivity and electricity to them. So if one data center goes down, the other two, the other one or two don't go down. And you can put your infrastructure in an availability zone, which then spreads it across those different data center buildings. And that again upgrades your SLA to 99.9 up to, I think, only like 10 to 15 minutes of downtime per month potentially with a 99.99. So you're building availability, you're building high availability and resiliency within your environment, and then we build then off of that potentially utilizing region pairs for a multi-region disaster recovery. And then we are not necessarily getting benefits from an SLA standpoint, but we now have disaster recovery, we have resiliency in our network. So if a entire region goes down, we have the availability depending upon our recovery time and our recovery time objectives within our disaster recovery plan to bring that environment back up in a paired region that is still up and running. And I talked about in availability sets, having those on different hosts or different racks within the data center. And that's on top of that, you have what are called update domains and fault domains. And the update domains make sure that your infrastructure, your virtual machines are in different update cycles. So you can build those up to 20 different update domains and can then make sure that across your application that you're only losing one or two virtual machines for a short period of time while an update's taking place, and you still have at least some level of your environment still up and working. I'm sorry, Deepak, missed your question here. That's a good question back to the availability zones. How many data centers will there be generally in each region or availability zone? It's usually 3. It's some of the, if it's a newer region, it might only have 2, but at a minimum, there's usually 2. You can find out pretty easily when you create an availability zone, when you set up an availability zone, if it's not available for that region, it's not going to allow you to create an availability zone. So you know that's probably a newer region. They just haven't stood up the other data centers in that area. But generally, once one has been fully deployed, a region's been fully deployed, you're going to see 3 in terms of availability zones available. So, and then the last piece of the availability sets is the fault domains. And the fault domains is those different racks. So you can see from this diagram, we have 3 racks, but we have our servers spread on 3 different hosts across 2 racks. So key thing around availability sets is what you're doing with availability sets is you're saying, I'm going to be running this many servers. So your cost is going to exponentially increase on how many servers you're going to be running. So that's something important to know around cost governance is how resilient and available does my application need to be? If I'm only running in the United States during business hours, I'm not going to really worry about update domains because I can set my updates to be done in the middle of the night and I'm not going to worry about it. If I've got to run a global 24/7 operation, then this is important to me, and I want to make sure that my application doesn't go down, and that everybody, no matter what time of day, has access to my website, has access to my e-commerce, and to make purchases. I may need to put a little bit more investment into how my availability set is configured. And then again, availability zones, and this goes back to, you're going to typically see an Azure region built on 3 data centers, and you can see how that can expand then fault domains and the update domains across across regional buildings, data center buildings, physical buildings within that region, and those physical locations to up to 3. You're not going to see beyond 3 in any Azure environment, or even I think AWS still they build their regions on 3 data centers as well. That's typically the fundamental best practices, having those three zones, those 3 buildings within each region. And then just as we go into next week, when we talk about the infrastructure as a service, let's talk about a couple of just basic pieces that go into the Azure environment. The first is the Azure Resource Group. The Azure Resource Group is essentially the resource container for your resources. And generally, you're going to build a resource group based on the life cycle of that application. So good best practices, when you're building an application, you're building an application environment, to put all of the resources for that within one resource group. And then if that depreciates and is no longer needed, you can delete that resource group and the resources within there. You also have the security within that resource group at the resource level, as well as utilizing role-based access control to control all the resources within that environment, or down to the resource level of setting up your owners, contributors, and readers of that of those resources, which we'll talk about more when we get into security and identity management. And then, but so it's good. Like I said, it's a good practice to keep those, to put those into their own resource group. Here you can see an example of the slide is showing, the resource group is putting, your web and database, your virtual machine, and your storage for a particular application in one resource group. Or you could do it another way, where you've got all your virtual machines in a resource group, all your storage accounts in one resource group, and your web apps and databases in another resource group, all your platform services. It's up to you how you structure it, but it's good to determine a organizational type structure and stick with it is the best practice. And then last thing to cover this week, because we covered a lot, is Azure Resource Manager. And Azure Resource Manager we'll get into next week, but it is the web GUI for creating your subscription, your resource group, and your resources. It's that management layer to go in and see what you've got out there, how you create, update, control, and how you access all of your entire Azure subscription, and go between subscriptions if you have more than one subscription. So important just to understand Azure Resource Manager, also known as the portal, as portal.azure.com, is the name of that, and the formal name is Azure Resource Manager. So important to understand what Azure Resource Manager is, and if we don't say Azure Resource Manager as much as we may have done so a year ago. We just call it the portal now, mainly because if you got into Azure, in early 2019, there was still the classic portal, and then there was Azure Resource Manager. The classic portal has since been deprecated and removed, and nothing's on there anymore. I don't think. There may be some organizations that might have some older stuff, but I think Microsoft has moved everything into Azure Resource Manager. So it's important to understand that, what that is, and how all your management groups, subscriptions, resource groups, and then all of your resources are in there. So that is everything for today. So we've gotten through a lot of the foundational pieces and all of that. When I was going through creating and structuring this presentation for everybody, I'd given the Cloud Lunch and Learn team, how I was going to break out 4 of these, and they're going to break out a little bit different as we go each week, because I was just kind of looking at how from a time standpoint. But next week we're going to cover the core infrastructure as a service, storage and networking. We probably will get into a little bit around databases, but then and then we'll get into a little bit more, I think, around identity management and some of the PAAS services, and then as well as some of the security services will actually be on the 19th, and then we'll go into governance and subscriptions on the last week of October. So a little bit different structure. Like I said, please, I just put a link to the Metrics That Matter survey. So if you could complete that survey, I would appreciate it from my MCT level. It's very helpful from that standpoint. I do see a question about the presentation. The presentation will go up on as a PowerPoint slideshow on the GitHub, Cloud Lunch and Learn GitHub repository here probably in the next day or so, as well as like Marco said, it's recorded, and that will go up on the Cloud Lunch and Learn YouTube page as well. So that is it for me. Make sure you fill out the survey, the Microsoft survey as well. And I believe Marco also wants to say a few words about the Cloud Lunch and Learn Ideathon as well.
Yes, Dwayne, you are right. Thank you very, very much. This was a great presentation. I really enjoyed, despite the fact that I'm a little bit amateur in this. So I learned many things. Thank you for that. Yeah. I just wanted to say I posted, if somebody didn't register to this session, they can do it by filling this Microsoft form. It's in the chat, so you can follow the link. You can register, whoever came later on. I have two things actually to say. The last thing, it's basically, we do have this new thing happening. It's going to happen on 24th of October. It's called Cloud Lunch Learn Ideathon, which you mentioned. It's basically an online event. It's an online challenge that brings people together to work together and build ideas to solve the real world problems. You don't need to worry about the coding skills. Implementation is not actually part of the challenge. So this event is meant to be inclusive to people who are non-tech. They can participate, bring your ideas, and that's it. The signing up can be done individually. I'm gonna post now on chat the link which is gonna take you to the sign up page. So it can be done individually, or you can join with the existing team, or you can sign up with your own team or friends or colleagues and take opportunity to apply your knowledge and skill to solve this challenge. The challenge is going to be around the dementia this time, but you can definitely learn new things, especially if you're the learner. It's going to happen on 24th of October, so please join us. It's amazing. We have already a couple of, I would say, 1 or 2 teams filled. So we need more people. So 24th of October, that will be awesome if you can attend, and feel free to register, and one later on during this week, we will organize and send you the email. The last thing which I wanted to say before we go on, we have actually a festival of meetings or meetups during this week and the next one. So basically today at 6 p.m. GMT +1, we have a meetup in relation to the Kubernetes series are starting. It's going to be around what is Kubernetes and how it's used. Security with AKS. And next week, of course, we have again Dwayne happening on Monday. It's going to be a second part, which he already explained about it. But we have on this Wednesday as well, actually on Tuesday, tomorrow, we have a Microsoft Azure virtual tutorial series happening. It's going to be around 9 o'clock in the morning. So just in case if you're able to attend, feel free. And this Friday, we have again the second series of the governance and automation series. It's going to be about what is Azure governance and why you need it. Vukashin is going to take over that. So feel free to join us on Friday. And of course, thank you, Dwayne, for delivering this great session. and thank everyone to joining us on this session. Feel free to use later on our YouTube channel to follow up and to see this session again if you need any help. However, I wish you all a great day and see you next week then.
Yes, thank you, everybody. Have a great day.
Cheers.